Good morning, everybody, and welcome back to Next Door NetAdmin. This week, Google pwned itself, and I'm going to talk a little bit about the background of how this came about, and then I'm going to talk about what actually happened. There's a spec in modern browsers for something called service workers. Service workers are essentially a separate thread, a separate process that gets spun off from the main browser process in a hidden window. And you're like, a hidden window, this sounds suspicious. But it's actually not. It's essentially a JavaScript file, a little program that allows the website that it came from to interact with the activities that the user is performing. As an example, if you use a program, a separate program from your browser like Outlook or Thunderbird to send emails, that's an association in your file system. But if you have it such that when you click an email link on a web page and it opens webmail, like Gmail or OWA or Hotmail or whatever, redirecting that within the browser itself isn't a function of your file system. It's a service worker working in the background. When you say, yes, I'd like to use Gmail to open web requests that are trying to send email, that has to be processed in the background, and it has to essentially catch this, say, oh, it's a mail link, I'm supposed to send this to this web page, and then on this web page, I'm going to perform the actions to open a new email, address it to the person in the email link, possibly add a subject line, or whatever else is associated with that mail to link. Service workers are the function that make this happen. So service workers are essentially little JavaScript programs that are running in a hidden browser window, and they can intercept navigation requests, they can modify resources, and they can do some of the stuff that makes progressive web apps actually look like they're working in the same way as a traditional program. Okay. There's also something that all browsers implement called a fetch API. This essentially is when your browser is going to download something, a large file, let's say, there's a couple of things that can happen in doing this. You could start at the very beginning and then just kind of go bit by bit through the whole thing. And if you're doing that, it's vulnerable to a few things. One, it's just a single thread that's doing it. The site on the other end might be handling many different transfers at the same time, so your speed of download may not be actually what your connection can handle. It might just be you're one of many different requests that the source web server is handling. Another thing that might happen is if you close the browser, what happens to your download? It stops, right? It goes away. Okay. That might not be great. That might not be what people expect of their browser these days. The Fetch API, or rather, some of the things that can happen when downloading large files is your browser can set up range requests, and it'll essentially put, let's say, for the sake of an example, 4 requests, each one for a quarter of the file that you're attempting to download. And because you've got 4 requests that the source web server has in queue rather than just one, you can expect that you'll get chunks from all 4 of those requests every time it goes through its queue rather than only getting one chunk. And so it actually speeds up your download because you're getting the source server to send more information more frequently by having multiple requests in its queue. That's pretty standard. The Fetch API just goes and abstracts these sorts of things a little bit more, where rather than the browser or the web page specifically say, okay, I want you to download this file and do it in chunks, or deal with a CDN or anything like that. The fetch API essentially allows it to just say, hey, go fetch this file and let me know when you're done. That's basically what it is. Fetch this, let me know when you're done. Okay. And then you can have a control in the browser, whether it's like a media player or something else, that says, okay, I want you to preload a bunch of this stuff by passing it off to a fetch. And then the fetch runs, tells the media player, okay, your data is ready. And it's like, okay, so I'm done buffering and I'm just going to start playing now. All browsers implement both of these things, service workers and a fetch API. Chrome and Chromium specifically, which, remember, Chromium is the foundational layer that handles Chrome. Chrome is built on top of Chromium. Edge is built on top of Chromium. There are many other browsers that are also built on top of Chromium as the open source foundational layer. In Chromium, there's an additional thing that's implemented, which is background fetch API. Okay, so this is going to work like the fetch API, where the browser is told to download something and then just let the control know when it's done. But the background fetch API passes this off to a service worker, which runs hidden in a hidden browser window that you can't see and you can't access. And it's intended that this is, okay, so I want to download something pretty heavy for this media player plugin that doesn't want to handle it all. So it's just going to ask the browser, here, go download this and let me know when it's done. Well, what happens if the user closes the tab? If the user closes the tab and the video player plugin goes away, then it's not going to keep waiting for this fetch to happen, and the fetch will stop. But with background fetch, you could have, this video media plugin passes off, hey, I'll fetch this in the background. And then if the user closes the tab, the fetch continues because of it's a service worker. And then next time you go to that web page and open it up, hey, it's already been cached and preloaded and it's ready to go. So that's what it's intended for. However, turns out you can also, send this service worker whatever else you want as a background fetch. And because it's a JavaScript program that runs on its own in a hidden browser window, it can do anything that one of these programs will do. Now, that's somewhat limited. It can't read all the files on your hard drive. That's not something that these programs are allowed to do. It can't snoop on what you're doing or anything like that. These service workers are specifically constrained to what they can request and what the user has chosen to give them. You don't click on a mail to link and automatically open up Gmail. You have to have said, yes, I want to actually register this action with this service worker, with this thread, before it'll actually do that. So absent that kind of user, hey, yes, I want to do this, what these things can do is somewhat limited, but it's not completely limited. Your browser can still act as a browser, which means, yes, with background fetch, here, go fetch this, and turning it over to a service worker, this service worker can do many things. And because it's associated with background fetch, it can continue, fetching things according to what the program says. So what can happen with this? Well, what looks like can happen is you can have any website that has this JavaScript program and calls a background fetch request to fetch and execute this JavaScript file, which is how the service worker launches. And then it can talk to a remote command and control server. This is essentially making it part of a limited botnet. And if the command and control server tells 50,000 of these machines, hey, go make a request for this web page at this target site, then suddenly the target site gets 50,000 requests out of the blue all at the same time. And that could knock it offline or degrade the service. This is a standard distributed denial of service attack. Another thing that it could do is these requests can also essentially allow somebody to use your browser as a proxy. And it could be a proxy for these attackers. It could be a proxy for everybody. Proxy for hire, essentially. So your browser could be forwarding somebody else's requests to the internet and making their traffic look like it's your traffic before it gets bounced back out in some other fashion. There are other legitimate tools that do this sort of proxying. Snowflake for Tor does the same thing, helping users in censored areas of the internet get access to the open internet. But those run explicitly with a user interface, and they tell the user that they're running. This could essentially do kind of the same thing, but completely hidden and without your knowledge or your consent. And that would be a problem. So that's the background on what's happening. Now, where does this Google pwning itself come into it? Well, this particular behavior, this vulnerability, we'll say, was reported to Google in late 2022, over 40 months ago. And Google hasn't done anything about it. Google looked at it and they said, you know what? Yes, there's at least 3 different developers that went, you know what? This is a serious vulnerability. And they classified this as a severity 2. It's actually the 3rd highest, because the highest is a severity 0. So Sev 0, Sev 1, this is Sev 2, the 3rd highest on the list. That's still pretty high up there. That's not a low priority. We know this because Google published this open bug report earlier this week. And as part of that, they also included a script to exploit this and actually kick off one of these malicious actions. This is actually fairly standard to have in a bug report. You need something that proves that this bug exists so that developers have a known exploit that they can test against. They can say, okay, I've made this change. Does it stop this script? Does it stop these actions from happening? So that's a standard part of a bug report. But you wouldn't usually publish that while your software is still vulnerable. And that's what Google did, unfortunately. They published it, and the person who originally reported the vulnerability went, oh, wow, after over 40 months, they finally got around to fixing it. That's amazing. And then they tested it, and they went, oh, no, this isn't actually fixed. Google's just told the entire world how to exploit this without doing anything to fix it whatsoever. And, you know, there was a lot of running around and figuring out what to do, and the bug report got taken down, or it got made private again so that the entire world can't see it. But this is the internet. Once you put something out on the internet, yeah, no, people have that. People have this script now, and they know this is something that's been around since at least 2022. Google hasn't fixed it yet, but they just told the whole world how to use it. And so right now, there's really not a lot that anybody can do about it because it's in Chromium. Even if Google fixed it in Chrome, what about everything else that's built on top of Chromium? And even when they do fix Chromium, That doesn't mean that Edge or any other browser built on Chromium picks it up right away. Google is going to have to fix Chromium. Then that's going to go into Chrome. Microsoft is going to have to pull this into Edge and then, make sure that their customizations of Edge also work with whatever the bug fix was in Chromium. And then they're going to have to push this out to all the Windows machines around the world. This could take quite a bit of time. And that's why when vulnerabilities like this are reported responsibly to a vendor, which in this case, yes, it absolutely was reported responsibly. The developer told Google about it privately, did not tell anybody else, because they know, hey, this is something that's going to have to go into code, then it's going to have to be pushed out in updates, and you know what? The actual public bug report and credit for discovering the bug will come, but it has to come after everybody has updates, because otherwise you're essentially releasing a 0-day on everybody, and that's not responsible. So the developer did that. Why Google has sat on it for over 40 months when they already have had multiple people say on their staff, say, this is a serious vulnerability, and they've classified it as the third highest severity, why they've let it hang around for 40 months plus, who knows? Maybe it's difficult to fix. I don't know. Chromium's really the only browser that implements this background fetch API, which connects service workers and the regular fetch API. Firefox and Safari, at the very least, do not implement this, so they're not vulnerable. They have service workers, same as Chromium does. They have a fetch API, same as Chromium does, but they don't have a background fetch API. And what does this look like if it actually happens to you? Is this something that people can see? Maybe is the answer to that one. In Google Chrome itself, your downloads window opens as if you're trying to download something. You can close it and it might reopen again, and you might go, that's really annoying. I don't know why it's doing that, but it's a bug of some sort. It might actually be trying to download something using background fetch API in a hidden browser window that you can't see because you're not supposed to be able to see it. On Edge, you might get a downloads window open, but you might not. And it'll probably only happen once. And that's it. And because these service workers are supposed to stick around, and because modern browsers often preload parts of their code into memory so that they're faster to open when you click on it, these things will keep running in a hidden browser window even if you close your browser. You can restart your computer entirely, and they'll relaunch themselves again in a hidden browser, because that's how it's designed to work for progressive web applications, for speedy browser loads, for everything else. It's one of those things that there's not a lot you can do about it, unfortunately, other than not use Chromium altogether, which may or may not be a suitable solution for you. Otherwise, we're kind of stuck waiting for Google to, actually push out a fix, and then hoping that Microsoft and everybody else who runs on top of Chromium also picks up that fix and pushes it out pretty quickly. It is what it is. The only saving grace, really, is that it can't access all the files on your hard drive. It can't monitor your typing and everything else that you're doing, particularly outside of the browser. It's constrained to only being able to do what a browser does on its own, absent user interaction. So if it was something that let the browser do a bunch of things that a browser shouldn't be able to do, that would be a huge thing. But because this is really limited to, okay, your browser might, start performing DDoS attacks on other unsuspecting websites, and you don't know anything about it. Or your browser might allow other people to proxy their traffic through your computer like some kind of low-rent VPN. That's all that it is. So, as far as I have seen, it has not made a bunch of, big splashy news websites or anything like that. But from a network administrator's perspective, that's still pretty bad, because there's a lot of applications out there that are written only for Chrome. You might be able to run them in Firefox, or the application might say, this isn't my preferred browser, I'm not going to work. So you might have some stuff that you're running corporately that you don't have any choice but to run something that's Chromium based. Or your users might just prefer Chromium. And your regular websites might be fine. If your regular websites, well-known, well-reputed websites get compromised and they have this little JavaScript file added to trigger a background fetch API request, even just visiting the website is enough. You don't have to click anything. So it's very difficult for even well-educated users to fully block and be wary of. So in some respects, personally, I'm on the fence of, this is a big concern. Well, it's not as big as it could be. It's bad enough, but it's not as big as it could be. I don't want to set people's hair on fire with this news. And also because there's nothing they can do about it right now. It's one thing to say there's this big vulnerability, you should go and install patches, go and install updates. But if there's no update to fix it, what do? There's really nothing that you can do, especially if your applications in a corporate environment demand the use of Chrome. So, for all the network admins out there, it's probably useful to know that these sorts of things both can exist and do exist, and that Google has helpfully told the entire internet that they're vulnerable to this, and this is how exactly you can exploit it. But for regular people, just keep installing updates when you can, because that's probably as much as you can do, short of moving to a different browser entirely. But even that, there's other bugs in the world that might affect Firefox or Safari, and Chrome may not be vulnerable to. There's no perfect browser out there. It's just, right now we can say that everything based on Chromium is vulnerable to this particular vulnerability, and Firefox and Safari are not. So that's pretty much it. Hopefully you found this interesting information and not too threatening or, paranoia inducing. If you have thoughts on other things that you would like to see me talk about or see me demonstrate, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.